Hi, this is Joe Bolen, and welcome to Learning VisualBasic.net. In this lesson, we're going to look at how the computer does arithmetic. Now, for you that may be uncomfortable with arithmetic, don't be afraid to learn about how the computer does arithmetic, because it is a very simple type of arithmetic the computer uses. If you decide later on you want to become a professional, remember that you're going to have support people around you. For example, you'll have an accountant who will give you the formulas that they might need for a program, or you might have an engineer that will give you the special calculations needed for a special function. So don't worry that you don't maybe have a great math skills. The important thing is to take their formulas, their ideas, and turn them into the language of the computer to do those kinds of computations. So let's learn how the computer does those kind of computations and learn a little bit about the order of precedence of those computations. So let's take a look first of all at the arithmetic operators that are used on a typical type of program. We're all comfortable with addition, hopefully, and when we code addition, we use the plus sign when we just talk about algebra type and simple math. And the computer uses the plus sign as well. So a 7 plus 2 will give us 9. And subtraction, once again, we use the minus sign for subtraction. And so 7 minus 2 would give us 5. Now, in multiplication, we use a little bit different symbol. A lot of times we'll write a X for multiplication, but in the computer we use the asterisk symbol for multiplication. So 7 asterisk 2 will result in 14. And then we also do division, and we call this especially floating point division on that we're used to coding and doing by hand. In this case, 7 divided by 2 will give us 3.5. But something new to a computer is what's called integral division on that. And when we use this, we use the backslash instead of the forward slash. And here we get 7 backslash 2, or integral division, and we're only going to get 3. What we get is the amount that 2 will go into 7, and we discard the remainder on that. So that this is one way to get a whole number from a division. Now, a little bit different than a whole number from a division is using modulus type of processing. And here's where we want to get the remainder. So if I take 7 modulus 2, I'll get a remainder of 1. 2 will go into 7 3 times with a remainder of 1 left over, and so I get the result of 1. Now, what is especially nice about modulus 2 is that it'll tell us about even and odd numbers. A lot of times that's fun for coin flipping and other activities. So we'll know if we have an even heads or an odd, might be tails for us. So this one gives us the remainder, not the primary part of the 3.5. Exponential, raising something to a power, is very similar. We use the caret, and so 7 raised to the power 2, or 7 times 7, gives us 49. And then there's 2 other kinds of operations used in a computer. Unary negation, and that's just a minus sign in front of a number, and so this would be a -3. And also the positive side of that would be a plus sign in front of a number, and here we have a +4. So these are all the operators basically that the computer uses. Now, one thing that is important to remember though is that all these, if they're used together, have an order of precedence of how they're done. And in the order of precedence, we do things from left to right. And when I was growing up, I used the phrase, "Please remember my dear Aunt Sally." Now, there are other phrases or mnemonics to remember the order of precedence of how to process an equation. Some have "please" or "excuse my dear Aunt Sally." But the whole idea is the first one, please, reminds me of parentheses. I'm going to do things inside of parentheses first. The raise, or using exponential one, is under the remember. So if I remember or excuse dear Aunt Sally, I'm raising or doing an exponential with the caret. So we do parentheses in the caret, then the M stands for multiplication, the D stands for division, and floating point occurs first, then integer division, and then the ANT is for addition, and the S out of Sally is for subtraction. So if I remember this little mnemonic, please remember my dear Aunt Sally, and know that I do things from left to right, then I'll know how an equation gets evaluated. And so here we see an algebraic expression on that, and it's going to process, first of all, the one with the caret, where we're doing exponential, so it'll do that which is inside the caret, and then it's going to do the multiplication on these two areas, and then finally it'll do the addition. So this equation that I have here is the same if I put parentheses around it. First I'll do inside the parentheses the exponential, then I'll do the multiplication on these both sets of parts of the equation, and then finally I'll do the addition parts to get my results. And we're going from left to right. So order of precedence is the second part we need to remember. So let's take a look inside the computer and actually see these being tried out. So let's go into Visual Studio, and I'm going to create a new project, and I'm going to create what's called a console project. So I'm going to go to Visual Basic Templates, and I'm going to go to a console application. Now I have Network Framework 4, but you could use a more current version. Current version right now at this recording is 4.52 on that, but 4 is fine for our purposes today. So it's going to be a console application. Now a console application is a text-based type of program where we have basically using the keyboard for input, and we're getting our results as a text-based output on the monitor. So I'm going to call this Math Demo and hit OK. And our project started up. I'm going to change the size a little bit to make it easier to read. And I think I'll go full screen to make it even better for us to see. We see here basically the simplest part of a console application. We have a module level versus a class, and we're going to have the beginning of our program begin inside the submain area of a procedure, and it'll end with the end sub. So we're going to basically have two lines of code that we're going to work with today. We're going to do a console write line, and I'll just do that for now. And then we're going to stop the program from ending by doing a console read key to hold it there till we're ready to allow it to end. So with just these two lines of code, nothing's going to happen, but we'll see the console first appear. So I'm going to hit the Start Debug, and we'll see the console pop up and hold until I hit the any key, and then it'll exit out. So we're basically bringing the console up with the right line, and in here we'll put some information to write out to the console, and then the read key holds things till we enter something on the keyboard. Okay, let's put something into our program to learn a little bit about math. Well, let's do that 7 plus 2. Well, we know that should give us 9, so let's do it. I'll hit the Start button, and in fact it gives us the answer of 9, which is what we should get and what we expect. Let me copy this line. I'm going to copy over it with a Control-C, add a line, and do a Control-V to paste it in place. And let's now do the subtraction. And this should give us a -5. Let's run this one. And in fact, we get the addition is 7 plus 2 is 9. Subtraction is 5. Let's get it a little bit more complicated. Let's add another line. I'll copy this one again. Drop down. And this time we're going to do a division on that. And for this one, we're going to do a floating point division. So I'm going to use the /. Let me do this. We should get 3.5, which we do on that. So 7 divided by 2 gives us 3.5. Now let's do it with the integer type division. I'll copy this line, bring it down. And this one uses, instead of the /, it uses the \, which is different than we're used to seeing. On that, let me get the \. And this one should give us just 3 when I run it. So I'll hit the run. And in fact, we see that it gives us a result of 7 with integer division, giving us 3 when we divide it by 2. Okay, let's do the modulus one, which is a new one for many to see. I'm going to do a console right line. And inside there, I'm going to put 7 mod 2. And it'll take 2 into 7, which will give us 3 with a remainder of 1. And that 1 will be what we get back as a result. And in fact, that's what we do get back. And once again, this is very good to do heads and tails of a coin toss, because when we do this, we'll either get a 0 or 1 for our results. Another one we might do is do multiplication. So I'm going to do a console right line. And this one will be a 7 times 2. Let's run this one. And we get 14, which is 7 times 2. Great. And the next one we'll do is just the unary negation. So I'm going to do a console right line. And I'll just put in a -3. Whoops, sorry about that. And that should just give me a -3. And that's all I get. And the positive side of that would be putting in a positive value. So I'll be put in a +4, for example, and we'll get just a +4. Give it spelling right here. There we go. And we'll get just a 4. So we can see the different arithmetic operators being used: the addition, subtraction, the floating point division, the integral division, the modulus, multiplication, and then we'll also see the unary negation and positive values. Well, those are basically all you need to know to do many of your math exercises, but there are also some that are built into the system. Let's take a look at a couple of math functions. One thing that would be the opposite of this would, well, first of all, let's do console right line. And let's do a 7 to the power of 2, which is built into the system with a caret. And that should give us 49 when we run it. And in fact, we get 49. Now let's do the square root, which is just the opposite. Now for this, we have a built-in function. So I'm going to do right line. But I'm going to use the math function. And I'm going to use the square root function of this one. In this case, I'm going to take the square root of 49. And the square root of 49 will be 7. And there we see it. 7 times 7, or 7 to the second power, gives us 49. And the square root of 49 gives us 7. And there's even another one I'd like to show you, console. And now I'll use the math function of round. And we'll take 3.48 on that. And we'll see that this rounding function will round this. In this case, it will round to the integer on that when I run it. And we'll see it rounded out to 3 on that. So we have built into the system many different math functions. And one of the nice things about the Visual Studio environment is if I put my cursor on a function like the math symbol and then hit F1, it'll take me to the internet and pull in from Microsoft information about the math class. And in the math class, there are a number of trigonometric functions as well as other functions like minimum and maximum that help us in processing things. So if you have any math homework that you'd like to do, you can quickly take advantage of the math functions as well as this simple arithmetic available to us. And remember that the F1 key placed on a spot gives us context-sensitive help on many of the things within Visual Studio. Now let's go to the idea of the order of precedence. Now I'm going to write a formula that will initially be somewhat confusing to look at and figure out what it is. So I'm going to take 2 times 7 and I'm going to raise that to the power of 2, and I'm going to then add 4 to it, and then I'm going to multiply by 2 and do a -6. Now, when you first see this, this might be hard to read, but remember we do it by what's inside parentheses first. In this case, we're going to look at raising it to a power of 2, 7 to the power of 2, which will give us 49. Then we're going to do multiplication next, which is 2 times 49, and also 4 times 2. Then lastly, we're going to do our addition and subtraction. So this basically boils down to this. If we were to do it piece by piece, it'd be basically 7 times 49 here. And then we'd add 4 times 2 minus 6. And that's the same thing. And if I were to take it even further, it's the same thing as taking 2 times 49, which is 98. And then I'm taking plus 4. No, I'll take that back. I'm taking it times 8. And then I'm minusing 6 from it. So this is the equivalent of this. And of course, ultimately, this should be equal to 98 plus 8 is 106, minus 6 be 100 even. Now, if all these are correct, this equation up here will be the same as this one, as this one, as this one, and we should see the same value of 100 for all of them. Let's see if I did my order of precedence correctly. And in fact, they all turn out to be 100. And that's exactly what happened. We did it by, first of all, looking at left or right. Then we did that which was to raise something exponentially. Then we looked at the multiplication and division. Then we looked finally at addition and subtraction, and they all came out to be the same. So this basically is all we need to know about how a computer does math as we process things. And so it doesn't become that hard to program things. Now we'll learn a little bit more later on about using variables and other types of processing, but essentially the computer does very simple math, and we can take advantage of its speed and accuracy to do math for us. So don't be afraid to learn how to program a little bit with it. The important thing is to remember the order of precedence when we're processing on that so that we have things done correctly. Remember, the order of precedence is from left to right. Please remember or excuse my dear Aunt Sally. We do parentheses, then we do the raising or exponential with the caret, then multiplication and division, then addition and subtraction as how we process a formula. So it's very similar to the kinds of math we are accustomed to in school, and so coding is not that difficult. So stay tuned to next time. In the meantime, get your hands a little dirty with some math and try it out. Take care.